We're going to talk now about exponential functions. When I talk about exponential functions, I'm talking about functions that are in this form. Y equals A times B to the x. This A is what we refer to as the initial value. When we talk a little bit more about the graphs of the functions, that initial value will also be the y-intercept of the graph. This value of b right here is known as our growth or decay factor. So depending on that value, we'll be able to tell whether this function represents exponential growth or exponential decay. We'll look at some examples here momentarily for that. And again, our variable up here, our independent variable, is up here trapped in the exponent. So that's what makes an exponential function. So again, we already commented on the initial value being the y-intercept of the graph. Let's talk a little bit about the growth or decay factor and what we're looking at there to determine whether we're dealing with exponential growth or decay. So if the b value is greater than 1, the function represents exponential growth. So any b value greater than 1 will be a function representing exponential growth, or an exponential growth function. For b values greater than 0 but less than 1, so something between 0 and 1, the function represents exponential decay. So again, just a quick review of what I said there. If this b value is some number greater than 1, we're dealing with a function that is an exponential growth function. If this b value is something between 0 and 1, we're dealing with something that is an exponential decay function. Like, do we want it to be 0? No, because 0 to any power would just be 0, and then again we wouldn't have anything that was growing or decaying at all there. And then for a similar reason, we don't want it to be 1, because if we take 1 to any power, we just get 1. And again, we don't have something that's growing or decaying, so it wouldn't be representing this exponential growth or this exponential decay that we're talking about. I've also excluded the negative numbers, if you've picked up on that. You can maybe think about why. If you start taking negative numbers to powers, does it grow or decay like we might be talking? Just kind of think about that a little bit if you want to kind of extend this thinking a little bit. But yeah, we're definitely not talking about negative values for this b with that. So, again, let me know if you have questions about the basics with that. I will, here in a moment, show you something about the graphs of exponential functions, growth and decay, and what they should look like as well. So now we're going to talk about the graph of an exponential growth function. So if I have something of this form, y equals a times b to the x, where b is greater than 1, it's going to be an exponential growth function. I commented earlier that this value of a, whatever it may be, is going to be the y-intercept. I'm just going to go ahead and mark that on this graph. Let's say this is a. Again, I'm not picking a number or anything for this example. I'm just doing this in the abstract. Whatever a is, that's where it crosses the x-axis. I'm sorry, the y-axis. I misspoke there for a second. Exponential growth functions are going to look a little bit like this. They're going to start out very, very low here on the left, and as they come up through that point, they're going to start to grow more rapidly. That's just kind of a basic shape of the graph if you're looking at something. This is a graph of an exponential growth function. It has a horizontal asymptote line here at the x-axis. So as I go to the left, as I move towards negative infinity, this graph approaches the x-axis, keeps getting closer and closer and closer to it. And then as I go towards positive infinity, this graph goes up. If I wanted to make statements about the domain of this function, the domain of this thing would be all real numbers. So in interval notation, that would be negative infinity to positive infinity. And the range of this function that I'm looking at right here, the range being the y values. This graph goes from here up like that. Again, it approaches the x-axis here, but it's not quite ever getting there. It's just getting ever closer and closer and closer to that. So the range there would be from 0 to infinity. So from here up, not including 0 again because it's not actually getting to the x-axis with that. So there's a little bit of background about the domain and range of a generic exponential growth function. Taking a look at an exponential decay function, so again, something of the form y equals a times b to the x, where b is now between 0 and 1, not including 0 and not including 1. Again, this value of a, whatever it may be, will be the y-intercept. I'm just going to arbitrarily mark that on the y-axis as a. And a exponential decay function will do the opposite of what an exponential growth function did. It will start out very high over here on the left and come down through, and then again, it's going to approach the x-axis. It has that horizontal asymptote line there of y equals 0, otherwise known as the x-axis as well. It's getting ever nearer to that axis as it comes down and goes towards positive infinity. I wanted to make the statements about the domain and the range of this graph as well. The domain, again, for this would be all real numbers. It goes forever to the left and forever to the right, so that would be negative infinity to positive infinity. There are no values of x that I would not be allowed to plug into that variable right there. Any real number would work for that. And the range of this function, again, the y values that are represented by this graph are everything from here up, once again. Again, not including the 0, because it is not actually getting to that axis. That's the asymptote line that it is approaching as I go towards positive infinity. So the range there would be from 0 up, once again, 0 to infinity, like so. Again, the initial value representing where the graph crosses the y-axis, and anything that is an exponential growth function will have this generic shape where it's starting out higher up here on the left and coming down as I go towards positive infinity in the x direction.